So this is a walkthrough for the Unit 14 test, percentages and compound units. I know some of you have already been through some of this, so feel free to fast forward through anything that you already understood. Deposit. So what we've got with a deposit, if you buy a cooker and perhaps they've got to order it in, you would pay a deposit to secure that cooker, to let them know that you're serious about buying that cooker. So in this case, you've got to pay 15% of the price of the cooker, and we're just wanting to find out what that deposit is. So we just want to find out what 15% of 320 is. And to find 15%, we have 15 divided by 100. We put that into our calculator. That gives us £48. That's it. That's what we have to do. Now here, I did do this walkthrough in one of our problem solving exercises, so you do have this written down already. I'm going to go through it again here if you didn't attend that lesson. What we've got here is a salesperson who has a basic pay. That means that this basic pay is the amount that Greg will earn regardless of whether he sells anything or not. So at the end, what we have to do is add in that basic pay. For every car insurance that he sells, 5% of the amount that he sells, he gets. That's how much he gets as his salary. Home insurance, he gets more, he gets 10%. And you can see the cost there of each of those items. You can write yourself out a new table. That's what I did in the problem solving exercise. For here, I'm going to write 5% of this amount, 10% of this amount per car insurance that they sell, per home insurance that Greg sells. So what is 5% of £200? So we do our formula again. This is 5% as a decimal, well, as a fraction. Put it into calculator, it would be a decimal. That's a multiplication sign. 5 divided by 100 multiplied by 200 gives you £10. So for every car insurance he sells, you would get £10. Here, what we're looking at is 10% of 350. I'm going to do it down here. 10%, which is 10 divided by 100, of 350 means that for every car insurance they sell, it is £35 of income. So he sold 6 car insurances and 4 home insurances. So we've got 6 lots of car insurances. So that's the £10, 6 lots of £10. For all the car insurances that Greg sold, he got £60. For all the home insurances, that's 4 multiplied by, and this time it's £35 for every car insurance, home insurance that was sold. 4 multiplied by 35 is £140. And remember, we need that basic pay. So what we're doing here is we're then adding on that basic pay of 530. That's the basic pay. And then we add them all together. What we end up is with £720. So the take-home pay, well, maybe it's actually before tax and national insurance is taken off. But what it's doing is, what's the amount that he earned? Well, actually, he earned £720. So we'd put £720 here. So what we're doing here, we're looking at the percentage increase. We're looking at an increase and we're looking at percentage. Just of company A. So we're just looking, in this first question, we're looking at these 2 figures here. What's the increase in sales? So the first thing we're going to do is work out what the increase is on sales. So we take our 388, we subtract 320. 388 subtract 320 gives us 68. Now we know it's in millions. but this is the increase. But we need the percentage increase, so we're looking at 68 as a percentage of the original amount. Remember when we were doing the football shirt example, we were always looking at the original amount. So this is 320. 68 divided by 320 is 0.2125, which as a percentage you multiply by 100, which gives you 21.25. Now I haven't rounded that because actually it's exact. This is an exact number. Write the exact number. Don't try and round something unless your calculator display is absolutely full of numbers. Which company had the most sales per worker? Well, what we're looking at here, we're looking in 2014. We're looking at the sales per worker, and the formula sales per worker equals the sales, total sales in 2014 divided by the number of workers. So what we're looking at for company A. Now, I'm not going to zoom back up and forwards because I think it'll be annoying, but if you've got your original paper in front of you, you can do that, or you can zoom backwards and forwards on the video to see where these numbers come from. So company A, we've got sales divided by workers. Now the sales for company A was 38, and now here I have to spell it out in millions, otherwise it won't be correct. Or you could just put the millions on at the end, but I'm going to put the millions on here so that I put exactly what I need to put into my calculator and I don't forget to look at the millions. 3,000, which means that for company A, the sales per worker is 121. Oh, no, that's a... Can I go back? Yeah, there we go. 250 sales per worker. So that's company A. Now with company B, so we're now looking at company B. We're looking at sales per worker, and this time we're looking at 57 million. And that is a zero there, by the way. 640. So they only have 640 workers. And if you put that into calculator, you get 89062.5. Again, sales per worker. And then you have to write a communication statement. To get those 5 marks, you have to write a communication statement. Therefore, company A has the most sales per worker. Question 4. 240 students, 15%, so we're looking at 15%. And we know how to do this by now. 15% of 240. 15% of 240 gives us 36 students. A third of the students are female. How many students are female? We're looking at a third of, multiplication is just like the of, 240 gives us 80 students. Eighty of the students walk to school, 60 cycle. So what we're looking at is a ratio. So ratio means we have to put it in a ratio. We're going to do walk to cycle. It says walk here, walk first and then cycle second. So that's the way we're going to do it. Walk is 80. You do that ratio sign, and 60 is the ones that cycle. Be very careful about the way round it is, or use your labels. I mean, if you use your labels and get it the wrong way round, it's absolutely fine as long as your label's the right way round. Then what we're doing is simplifying. We need to have it in the simplest form. So the first thing I can see is they've both got a 0. So I'm going to divide both sides of this ratio by 10, which gives us 8 here, and it gives us 6. Then I notice both of them are even numbers, so I can divide them both by 2. And if you can see, you can divide it by 20 to start with, absolutely great. If not, do it in 2 steps. There's nothing wrong with that at all. 8 divided by 2 is 4, ... 6 divided by 2 is 3, and that is your answer. Question 5. Now, I'm going to use the box method for this. You've seen the box method a lot of times now. 5 schools. So there are 5 schools altogether. One of the schools, now we're going to look at one of those schools. They sent both boys and girls. We're looking at boys first, girls second. Boys is in the ratio 1 to 2. So boxes. Boys have got 1 box. They've got 1 part. That's what that 1 represents. Girls have got 2 boxes. They have 2 parts. The school sent 16 boys. So in this box here, I know I can write 16. And because we're looking at parts, every single box has to have exactly the same number in it. 16, 16, 16. So we need to find out how many children were sent by this first school. The number of children, we basically count the boxes. So we've got 3 boxes multiplied by 16 children. 3 boxes multiplied by 16 is 48 students. So this first school sent 48 students. And then we're told the other 4 schools send only girls, so that perhaps they're girls' schools, but each of the 5 schools, including the first one, sent the same number of students. This means we take our 48 students, because that's what's sent per school, and multiply it by the number of schools. They all sent exactly the same number of students, and that's when we get the answer, which is 240 students. And that gave you 44 marks. Still trying to scroll down. There we go. Okay, question 6. Write the ratio in its simplest form. We've done this already. We know what we're doing. 48, 120. I'm going to start by dividing these by 4. I can see a common factor of 4 here. 48 takes us down to 12 to 30. I then can see a factor of 3, so I'm going to divide it by 3. It doesn't matter which factor you see, pick that factor and divide it until you can't take a common factor out of these anymore. These are now even. Of course they were even to begin with. And we get 2 and 5, and that is the answer. Sally has 3 different tiles. Each tile has a different number on it. Sally puts the 3 tiles down to make a number. So we're looking at 3-digit numbers. We have to show all the permutations of those 3-digit numbers. First 3-digit number is 1, 2, 3. I'm then going to swap around the 2 and the 3 to give me 1, 3, 2. You might have another way of doing this. It's absolutely fine. However you do it, make sure you've got all those permutations. I started with 1 before. I'm now going to start with 2, 1 and 3, and we've got 2, 3 and 1. And then I'm going to start with 3, 1 and 2, 3, 2 and 1. And remember to answer the question, how many different numbers can Sally make? Well, she can make 6 different. You'll have lost a mark if you didn't say 6. Okay, if I couldn't see the number 6 in there that was separate from the numbers that you created before, then you need to be able to do that. Okay, there are 90 animals at the rescue centre. 30% of them are cats. 38 of the animals are dogs. So we need to look at this logically. What are we talking about? Well, let's go and find out how many cats there are to start with. There are 60 animals, 30% of them are cats. We know how to do that. 30% as a fraction is 30 divided by 100, multiplied by the 60 animals, gives us 18 cats. 38 of the animals are dogs, so we just know there are 38 dogs. The rest are horses, so if we take our 18 and we add it to 38, use your calculator. It's a calculator, you can use it. Obviously if it's not a calculator paper you can't, but 18 plus 38 gives us 56. So there are 56 animals that are not horses. So we take our 60 animals, we subtract 56, and that gives us 4 horses. Moving on, question 7. So this is looking at compound depreciation. This is tricky, so I'm going to go through this and make sure I put lots of steps in. 25% depreciation. If we take 100 and we subtract 25%, we get 75%. So that is the amount that the car price depreciates every year. The multiplier, because we're going down, it starts with a 0. And then we're using the 75 figure, 0.75. So this is our multiplier that we're going to use going forward. Now I'm going to do this step by step. I'm not going to use the formula per se. I'm going to do it step by step. So at the end of 2013, the car started at the beginning at 4,800 and it depreciated by 7 to 75% of what it was. So we multiply that by 75. Put that into calculator. That gives us, oh no, at the end of 2013, actually it was 4,800. That's what it says. I've just checked my answer. So this is at the end of 2013. The value of the car was 4,800. This is actually at the end of 2014. So at the end of 2014, the price of the car was 3,600. The value of the car was 3,600. We want to know at the end of 2015, so we take this, the end of 2015, we have the new price, not the old price. I was about to put in the old price. We've got the new price, the new value of 3,600, and we multiply that by 0.75, which gives us that 2,700, which is the answer. Question 8. Now here we have compound interest. We need to use the compound interest formula. The multiplier is 2.5% on top of the 100%, which means we have 1.025. It's not 0.1. It's not 1.25 because we're looking at 2.5%. 2.5%. If we had 50%, the multiplier would be 1.50. If we had 5%, the multiplier would be 1.05, and that's why we have to have that 0 in. Don't get confused because it's got a decimal as your percentage. Still think of it as it's 2%. What do? I put a 0 in here. Or you just divide 2.5 by 100. That will give you that amount. Excuse me. So what we're doing here, we've got 1,500. This is the 1,500. We multiply by the multiplier, 1.025, and then we're looking at it being there for 3 years. So this is the formula. Have a look back in your exercise book. It gives us 1,615.3359338. So it's money. We now have a number that goes on forever, so we don't write the whole number. Because it's money, we round to 2 decimal places. Because it is money, we need to have pounds and pence. So we're rounding this to 2 decimal places, which we look at the 5, that rounds up, so we end up with 1615.34. It rounds up, we've got the 4 just here. Moving on. You bought a computer, it depreciated by 20%. We know what to do with that. We have 100 and we subtract our 20, which gives us 80, and therefore our multiplier equals 0. It's depreciation 0.80. It's going down. After how many years? Now what I'm going to do is do this individually. I'm going to work out each year as we go. So at the end of each year, the value of depreciation. So we bought it for £1,200 and we multiply that by 0.80. So at the end of year one, we work that out and we get £960. Remember, this is still pounds. So we start year 2 with £960 and it still depreciates at 80%, which means at the end of year 2, we have £768, which we put back in to the start, and we multiply that 0.80, which gives us 614.4. This is the end of year 3. Now we're still not at that figure. We're still not here, so it's not after 3 years. We've got to go again. 614.4. Make sure you keep the 0.4 in there, it's important. Which gives us 491.52, and beautifully they've left it as the exact number here, which means at the end of 4 years. So it's 4 years. After how many years? You need to write, for your communication mark, you need to write 4 years in order to get the third mark. 10. Account pays 3% compound interest, so the multiplier is 1.03. It's interest, it's going up. It's not depreciation, it is going up, it's compound interest. So what have we got? We've got £5,000. We multiply that by 3. We divide it by 100, because what we're looking to find out is that we want to find out what the interest is in year 1, and then we want to find out what the interest is in year 2. So I'm doing this step by step. I'm not using the formula, although I could do. This means we've got £150, and that's the interest for year 1. Actually, because we've got to find the tax on the interest, I'm going to do it year by year, because it's not just using the formula. So this is the interest that she pays, and on that, so she gets the interest. So she puts £5,000 in the account. At the end of the year, she gets £150 interest, but she has to pay tax, 20% on that interest. So she doesn't get all of that interest. She only gets some of that interest, and she has to pay 20% tax. So we need to find out what 20% of this amount is. 150. So 20% is £30 in tax. So she doesn't get 150. She actually gets 150. Subtract 30, which means that she actually gets £120 of interest in total. So that's what she adds to the first year. So the start of the first year, so I'm just going to write start of year 2, she has £5,000, which was the original amount, plus the interest subtract the tax, which means that she starts the year 2 with £5,120. We then have to do exactly the same as we've done already. We have to find out what 3% is of that new amount. So we take our 5120. We then multiply that by 3, divide it by 100 again. We have to find the tax on that amount. We take away the tax, so I'm just going to draw a line here. What we've got is the 15360. And 15360 subtract 30.72 gives us 2.88. So this is the amount that she gets paid. Last year she got 120 extra. This year she gets a bit more because she started with a bit more, which means that we start with the 5120, the start of year 2. We add the 12288. And that gives us 5242.88 pounds. And again, we don't round it. It's money. If it had another decimal place, then yes, we would round it. And because we're rounding it to 2 decimal places, they've made it easy for us. We don't have to do any clever rounding. Question 11. So there are 2 schemes. So what I'm going to do is draw a line down the middle. I like, when I'm presenting my answers, to show very clearly which scheme is which. So we've got scheme A and we've got scheme B. So we're going to start scheme A. Now, I haven't taken you through simple interest. What simple interest means is that you get the same amount of interest regardless of how much you've got in your account at the beginning of the year. So simple interest, the multiplier will be 1.04, or let's look at 4%. What 4% of 2,500 is? We multiply it by 4, we divide by 100, and that means that every year with this scheme you would get £100 interest per year. So we're looking at over 2 years. So we start with 2,500, and the first year you'd get £100 interest, and the second year you'd get £100 interest. It doesn't increase, the interest doesn't change year on year. That's what simple interest means. It's a lot less complicated than compound interest, which is why I focused on compound interest, but I forgot to show you about simple interest. So here it is, same amount every year. You work it out once, you add that amount every year that you're interested in. Scheme B, on the other hand, you use the compound interest formula. So we're looking at a multiplier. Let me just eke back in here. The multiplier equals 1.039. And then in scheme B here, what we've got is, we've got the original, 2500, and we multiply it by the multiplier, 039, and it's for 2 years. So we have to square that amount. We put that whole formula equation into our calculator, and we end up with 2698.8025, and this is where we do round up. It doesn't matter for this because we just need to know which gives the most interest, but to be complete, I'm going to write this as money. You can't have 0.25 of a penny, so I'm just going to write it here. If it was 5678, you would, instead of the 2, you would round it up. But here, so which one gives the most interest? Well, again, you need your communication mark at the end. scheme A gives the most interest, because it gives the highest total. You can work out that this adds £200 interest and this adds £198.80 interest, but we can see, because we've added it to the original amount, that this is the amount of interest. Question 12. So I like a table for this. I'm not sure I'm going to be able to get this into here, but let's have a go. So I'm going to draw the table in here. We're going the journey between A and B. We're going the journey between B and C. We've got 3 bits of information: distance, speed and time. We look at the question. The distance between A and B is 25, and I'm going to put the units because we might need to change some units later, and here 25 miles as well. The speed, I should drive an average speed of 50 miles per hour from A to B, miles per hour, and 60 miles per hour here. Now we cannot, if this was a total column, we cannot add the speeds together. Lots of people like to add the speeds and divide by 2. Rubbish. It will not work. Do not do that. We need to work out what the time is for each of the 2 distances, and then we can work out, well, actually we just need the time. So that's what we're doing. But some of these questions ask you to find out what the average speed is across the whole distance. You cannot add them together and divide by 2. So what we're looking at is the triangle, or the formulas, whichever way you remember it. Speed is distance divided by time. Now, I always label it so that I make sure my units are right. The distance is in miles. The speed is in miles per hour, because that is what's on the question. So my time has to be in hours, because I've got miles per hour as my speed. Now note, the answer needs to be in minutes. So right at the end, we need to come back and sort out the minutes. But for the time being, we start in hours. So what have we got? Well, we've got speed is distance over time, or we're trying to find out time. So time equals distance divided by speed. Distance divided by speed. And that's what we've got. We've got a distance here divided by speed. Distance is 25. Speed is 50, which gives us an answer of 0.5, which I can put in this table, and this is in hours. It's not in minutes, it's in hours. We do the same for B to C. So this was A to B, and then this one is B to C. We're looking this time at time being 25 divided by 60, which gives us 5/12 of an hour. I don't want to put that in a decimal because it's a recurring decimal. I'm just going to leave it as it is because it's a whole number. It is an exact, it's not a whole number, it's an exact number. So we're using this. But now what we have to do is convert those amounts into minutes. We need to find the difference between 0.5 hours and 5/12 of an hour in minutes. So what I'm going to do is I'm going to subtract these from each other. If this was not a non-calculator paper, I could do it as fractions. I could take a half and I could subtract the 5/12. I could turn it so that this is 6/12, subtract 5/12. Obviously, if it's not a non-calculator paper, you can just put this into your calculator, and please do. It means that we've got left 1/12 of an hour. This is an hour. a 1/12 of an hour is actually 5 minutes. And you could get to that by saying a 1/12 of 60 minutes. Sorry, yeah, a 1/12, there are 60 minutes in an hour. A 1/12 of 60 is 5 minutes. And so therefore the distance pops out straight away, and that is our 5 minutes. Density, we need a new triangle. We did do a couple of questions on density. I did show you this triangle a couple of times at the beginning of the module as well, so go back and have a look at it. We also did force and mass and volume, so that was the other triangle, but there weren't any questions on this test on it. We haven't dwelt on it for too long. We did have a look at the formula though. So what do we have? We have density, which is in grams per centimetre cubed, and actually I've made a mistake here. Density is grams per centimetre cubed, therefore the mass is in grams and the volume is in centimetres cubed. Now notice here, this is in metres cubed. We need it in centimetres cubed to use this formula. We cannot use this formula while it's in metres cubed. So what we're looking at, a piece of wood has a mass of X kilograms and a volume of this. Oh, and this is in kilograms and this is in grams, okay? So let's sort that one out first. We've got X kilograms, and therefore we want to convert it into grams, we have to multiply it by 1,000. So it's X multiplied by 1,000, which gives us, it looks prettier if we write 1,000x, and that's now in grams. Okay, so that's now in grams. I'm just going to put that separate. So it's 1,000x grams. If we're looking to convert this value here, then what we have to do is we have to take the 0.002 and then multiply it. If we're going from metres to centimetres, we have to multiply by 100. If we're going from metres squared, so if we were going from, there we go, 1 metre, and we're going to centimetres, we have to take that 1 and we have to multiply it by 100. That gets us to 100 centimetres. If we're going from 1 metre squared, we're going from an area, then this equals 1 multiplied by 100, but then we have to multiply it by 100 again, and that turns it into centimetres squared. And if we're doing 1 cubic metre, 1 metre cubed, then we have to take the 1 multiplied by 100, multiplied by 100, and multiplied by 100 again. So that's what we're going to do here. Multiplied by 100, multiplied by 100, also known as 100 cubed, but just spelling it out so it's clear. And this, if you put it into your calculator, gives you 2,000 centimetres cubed. So we now have what we need in the correct units. This is our mass. This is our volume. And we have to show that this is the density. We don't get to this density straight away. We have to show this density. So we don't use this in our calculation. We're hoping that this is going to pop out the end of our calculation. So we're trying to find density. Density equals mass divided by volume. We know our mass is 1,000x, and we divide that by our 2,000. Just leave the x as it is. Don't worry about what that x is. We know we need the x in the answer. We take 1,000, we divide by 2,000, and that gets us this answer here. And density is in grams per cubic centimetres. Now this actually wasn't on your exam paper, but it was one of the problem solving exercises I gave you. We have spelt it out on there, and I will give you, on Google Classroom, you actually have already the word example to this. I'm just going to show you it on the page, if you like, how I would lay it out. The first thing I've got to remember is that formula. It's still the same as the problem solving template. What is the formula? What formula do we need? We're looking at having to work out the volume of this prism. It's still the same triangle as we have just used. we're looking at the density triangle. So we've got density, mass and volume. We need the density to be in grams per centimetres cubed, which means that we can also write this as grams divided by centimetres cubed. Mass therefore has to be in grams, volume has to be in centimetres cubed. Now luckily we've already got this as centimetres, so we don't need to do any conversion here. We'll calculate the mass of the prism, and it's the mass, the grams, that we have to work out. So this time the formula that we're going to be using, we have to find out the mass. Mass equals density multiplied by volume. So we've got the density. This, we know that the density is our 6.6 grams per centimetres cubed, but we don't know what the volume is, and that's what we've got to work out. We are told that this, we've told all the dimensions of this solid triangular prism, so we have to now use our knowledge of volume to work this out. The first thing we've got to do is work out what this area here is. So we've got a triangle. This side here, the vertical height is 12 centimetres, and this length here is 5 centimetres. The formula, area of a triangle, equals half multiplied by base, which is the 5, multiplied by vertical height. It's not slopey height, it is vertical height. We don't have to worry because it's the same thing in this case, is because we've got a right angle. But some triangles, some questions are a bit nasty and give you both. So we've got base here. Base is the 5, height is the 12. We put that into our calculator, and the area is 30 centimetres squared. So the red bit here, the red shape here, is 30 centimetres squared. We then have to take that through this depth. So to find the volume of a prism, we take the cross-sectional area, I'm going to write it down, vol equals cross multiplied by depth. Now the cross-sectional area is basically the area at the end, the bit that is the same all the way through, the area that's the same all the way through the prism, if you chopped it like a stick of rock. So the cross-sectional area is what we've worked out here, which is our 30 centimetres squared. It's the area of the triangle. The depth is the one dimension we haven't used yet, which is our 15 centimetres. We then take the 30, we multiply by the 15, which gives us 450 centimetres cubed. So we now have our volume. This is our volume. We go back to our original equation that we had there. Mass equals density multiplied by volume. Mass equals density multiplied by volume. And now we can put the density in the question. This is in the question already, 6.6. Our volume is in the right units, it's in centimetres cubed, that's what we want it to be, 450. And we whack that into our calculator, which gives us 2,970. Mass, what units is it going to be? It's going to be in grams. And that's really important that you get that grams, that you state that grams, because otherwise we don't know. If you had thought it was kilograms, it would be wrong. So you do need to state that mass, that grams, that units. I hope that was useful. Send me a message, send me an email, let me know whether you'd like me to do more of these.